Okay, 1.6, we're going to start with writing an equation of a line. You should have this handout. If you haven't already, you should have folded it. It is a foldable. Okay, the equation of a line, it's going to depend on what you are given. So they may give you the slope and the y-intercept. Use the slope-intercept form. You should know slope-intercept from Algebra 1. It's y equals mx plus b. Remember, m is your slope. B is your y-intercept. Okay, for those of you who don't remember, your y-intercept is where the graph crosses the y-axis. You may not always be given the slope in the y-intercept. They may give you your slope and a point on the graph. If this is so, you want to use your point slope form. Point slope form is y minus y1 equals m times x minus x1. Okay. Next, they may just give you 2 points. The first one at x and y, this should be x2, y2. If this is the case, you're going to have to find the slope first, then you'll need to use point slope form. Now, remember again from Algebra 1, your slope is y2 minus y1 over x2 minus x1. Okay. Once you have the slope, then you'll use your point slope form, which again is y minus y1 equals m times x minus x1. All right, let's look at a couple of graphs. It says use the graph to write an equation of the line and interpret the slope. So first it wants an equation of the line. We're going to need the slope and the y-intercept to be able to do that. If you will look at cell phone costs first, we have the cost in dollars on the y-axis and the number of text messages sent on the x-axis. If you'll notice, we have this graph that crosses the y-axis at a point that they have marked. That is your y-intercept. So they've given you your b, where the graph crosses the y-axis is at the point 50. The next thing we're going to need to find is our slope. You can use the slope formula that I gave you, but with this particular problem, it's actually easier to just look at the graph. So if you'll notice, remember, slope is rise over run. So it goes up 1 and over 10. You got to pay close attention to the units. This is 50, 51, and 52. So up 1 over 5 over 10. So your slope is 1 over 10. Rise over run. We could also say 0.1, which I'm going to use because we're talking about money. This is cost in dollars. Nobody says 1/10 of a dollar. We say 10 cents. Okay, so to write the equation, we have everything you need. We need the equation, which is y equals mx plus b. That's the equation of a line. Plugging in our m and our b, y equals 0.1x plus 50. There's the equation. Now the second thing they wanted is to interpret the slope. What does this 0.1 actually mean? Well, it means that for every text message sent, it costs you 10 cents more. So that makes sense because the more text messages you send, the higher your bill is going to be. So for every text sent, the cost will increase by $0.1 or 10 cents. For every text message sent, the cost will increase by 10 cents. Okay, let's take a look at the math homework grade. Here's your homework grade. It's in percentages. It's on the y-axis, which makes sense. If you have 100%, you made 100. The completed assignments on the x-axis. If you'll notice that the slope here of the line is also positive because the more completed assignments you have, the higher your grade's going to be. However, it wants us to write an equation of the line. So last time we were able to look and see straight from the graph what the y-intercept was. However, there is not a point marking it. It looks like it might be like, I don't know, 78, but there's no way for me to actually tell, so I'm not going to be able to use the graph to find it. I do have 2 points, and if you'll notice up here, if they give you 2 points, you'll have to find the slope first, then use your point slope form. So again, our slope equation is m equals y2 minus y1 over x2 minus x1. Now you can label these, it doesn't matter which one's which. This can be your x1 and this can be your y1. This will be your x2 and this will be your y2. So plugging those in, y2 is 95 minus y1, which is 85, over x2, which is 20, minus x1, which is 10. Okay, simplifying that, 95 minus 85 is 10. 20 minus 10 is also 10. Our slope is 10 divided by 10, which is 1. Okay, once you've found the slope, then we need to use our point slope form. So we have y minus y1 equals m times x minus x1. Okay, the point that you use can be either of these 2 points. It doesn't matter. Just pick one. I'm going to pick the ones we labeled x1 and y1. So I'll have y minus y1, which was 85, equals m, which we know is 1, times x minus x1. x1 was 10, and that's it. Now, back to algebra. This 1, it can't just stay there. It's got to be distributed. So we'll go ahead and do that first. So I'll have y minus 85 equals 1 times x is x. 1 times negative 10 is negative 10. Now, next thing we need to do, it needs to be in y equals mx plus b form. That means the y needs to be by itself. In order to get y by itself, I'm going to have to add 85 to both sides. Whatever you do to one side, you got to do to the other. This will cancel. Negative 85 plus 85 is 0. Bring down my y. X doesn't have anything either. It doesn't have anything to be added or subtracted, so just bring it down. Negative 10 plus 85 is actually positive 75. We now have it in y equals mx plus b form. There's your equation. The next thing it wanted us to do was interpret the slope. So remember, our slope is 1. That means for every completed assignment, the homework grade will go up 1%. For every completed assignment, the homework grade increases by 1%. The homework grades are graded in percentages. That's how I knew it was 1%. Now, if you'll notice, this 1%, that's your slope. And same thing over here. It went up by 0.1. We knew that because that was our slope. So however much it increases by, that is the slope. All right, if you are stuck on this part at all, please pause this video and go back, re-listen to that part. If not, let's move on. All right, the cost of parking in a parking garage in Chicago is represented by the equation y equals 15x plus 20. That's Chicago. Y is the total cost. X is the time in hours. Now the table shows the total cost. So the table shows the total cost to park in a parking garage in Denver. Which city's parking garage charges more per hour, and by how much more? After how many hours would parking in both cities cost the same? Okay, so let's take a look at these separately. We have an equation for Chicago. I'm just going to use C. Chicago's equation is y equals 15x plus 20. But Denver, the table shows the total cost to park in Denver. So this is Denver. But we need an equation to be able to compare them. So I'm going to show you how to find it. This is an easy lesson. So the table, we need an equation. Grab your calculator, turn it on. If there's anything on it, clear it off. To get an equation using our calculator, you want to hit the stat button. Stat, and then edit. Press enter. You'll get an L1 and L2. These are your lists. This serves as your X and Y. So if you put your cursor up to L2, press clear, and go back down, it will clear the list. Again, L1, cursor up to L1, press clear, drop it down, it will clear your list. L1 is your X's. L2 are your Y's. So literally just plug in your X's. So for L1, I've got 2, 3, 4, and 5. And for my Y's, I will plug in, to get over to my L2, plug in 43, 51, 59, and 67. Okay, once you've done that, stat calc. You'll arrow down to linear regression. It's number 4. Press enter. Keep pressing enter until it calculates for you. So if you'll notice, it gave you y equals mx plus b. It gave you the formula, and it said, hey, here's A, it's 8, and here's B, it's 27. You can plug these numbers into the formula to get your equation for Denver. So based on your calculator, your equation for Denver is y equals 8x plus 27. So now we have an equation for both, and we can compare them. The first question is, which city's parking garage charges more per hour? Well, per hour, that's the X. So which one charges more per hour? Chicago. It's got 15, and Denver only charges 8. So Chicago charges more. Chicago charges more. But it wants to know how much more. Well, 15 minus 8 is 7. $7 more. $7 more. There's your answer to your first part of your question. All right, the next part of the question says, after how many hours would parking in both cities be the same? So if we want to know when they would be the same, we can simply set the two equations equal to one another. So we have 15x plus 20 equals 8x plus 27. Now once we've done that, we simply solve for x. That means we've got to get all the x's on the same side of the equation. I'm going to move the 8x, subtracting 8x from both sides. Whatever you do to one side, you got to do to the other. 8x minus 8x will cancel. That's what I wanted. 15 minus 8, that gives me 7x plus 20 equals, I'm going to bring my 27 down. Okay. I still have to get x by itself, so I need to move this 20 to the other side, subtract 20 from both sides. Our 20s cancel. I get 7x equals 27 minus 20 is 7. Almost there, but not quite. 7x, that's the same thing as 7 times x. The opposite of multiplication is dividing. So I need to divide both sides by 7. 7 divided by 7 will cancel, and I'll be left with x. 7 divided by 7, 1. So how long, or after how many hours would parking in both cities be the same? 1 hour. Okay. If you're confused, plug the 1 hour back in for x on both sides and see if they equal one another. Okay, moving on to the line of best fit. The line of best fit is a precise line of fit that models a set of data by using technology. I'm going to use a different color. A precise line of fit that models a set of data that models a set of data by using technology. A precise line of fit that models a set of data by using technology. I'm going to talk a little bit more in a second once we get going with correlation coefficient. So correlation coefficient, that's just a number, we call it R, from -1 to +1 that measures the strength and the direction of the correlation of two variables. So the strength and direction. Let's take a look at where your R equals -1. R equals -1 is a strong negative correlation. The negative refers to the slope. So if you'll look at the graph below it, you'll see that graph has a negative slope. Also, the strong correlation means that the points on the graph lie awfully close to a line where I could almost draw a perfect line touching all of those points. Compare that to a strong positive correlation. The closer our R gets to 1, the positive correlation is stronger. Positive refers to the positive slope. If you'll notice, the graph below it has a positive slope. Also, it's a strong correlation because the points on the graph lie close enough together that I can almost draw a perfect line through all of them. Compare the strong negative and the strong positive to the one in the middle. No correlation at all. Those dots are just all over the place. There's no way I could attempt to draw a single line that would come close to touching all of these points. That means there's no correlation. Now, whenever the line is almost touching all of the points, that is your line of best fit. It best fits the data. Okay, let's move on over here. Correlation coefficient continued. So the closer the value of R is to 1 or -1, the stronger the linear correlation. Remember, linear correlation, that is, it looks more like a line. The stronger the linear correlation. The closer the value of R is to 0, the weaker the correlation. Okay, let's use what we know to practice these two problems. It says use the linear regression feature on your graphing calculator to find an equation of the line of best fit for the data. Well, we've already found an equation using our calculator. It's the same type of thing. However, first off, we have a graph, but we don't have any points. We need to know what are the coordinate points on the graph. So you'll need to make a chart to list those. Okay, so for every point, we need to list the coordinate points. So we've got 1 and 5, over 1, up 5, over 2, up 2, over 3, up 1, over 5, up 2, over 5, up 5. All right, now that I have the points, I can plug those into my calculator. Again, it is stat, edit, Your L1, you can clear it or you don't have to, either way. Your L1, again, that's our x's, which are 1, 2, 3, 5, and 5. My L2s, that's 5, 2, 1, 2, 5. Okay? Once you get those into your lists, stat, calc, linear regression, 4. Press enter until it calculates for you. And again, it gives you the equation. It gives you y equals mx plus b. It tells you what your a is. It tells you what your b is. So using your calculator, you can write the equation. The equation here is y equals, our a is negative 0.08. You need to round. X plus our b, which is 3.25. Okay, that just came straight off my calculator. Now, your correlation coefficient comes straight off of your calculator as well. If you'll notice, my R value, your correlation coefficient is your R value. If you do not have an R value, follow these steps. Second, 0. Second, 0, you should see catalog. I want you to scroll down until you see diagnostic on. It's in alphabetical order, so just go down to the D's. Diagnostic on, press enter. Press enter again. Your calculator has to say done in order for you to have done what you needed to do. So make sure your calculator says done. Then you can go back. Stat, calc, 4. Press enter until you get what you need. And at this point, you should see your R value. Not R squared, just R. So our R value, or our correlation coefficient, is negative 0.07. Now, negative 0.07, we obviously know it's going to be a negative correlation, but we need to know if it's strong or weak. So if you look over here, the closer we get to -1, the stronger it is. Well, ours is negative 0.07. That's awfully close to 0. We call that a weak negative. Weak negative correlation. Okay, I want you to pause this video and try this one on your own. All right, welcome back. Let's get our table going. Okay, your numbers should have been 0, 25, 1 and 20, 2 and 15, 3 and about 9, 4 and 5. Okay, when I plug that into my calculator, remember stat edit is where you'll plug your lists in. You should have gotten an equation that looks like y equals negative 5.1 x plus 25. Negative 5.1 x plus 25. Your R value should have been negative 0.998 or 999 if you rounded. Now, again, the measure of the strength, negative 0.998. The closer we get to -1, the stronger the correlation. 0.998 is about as close as to -1 as you could possibly get. So that would be a strong negative correlation. Strong negative. All right, the last one is just some more practice problems. Again, I want you to pause this video and do this one on your own. Come back and check your answers. All right, welcome back. All right, let's go over the last problem. The table shows the humerus lengths and heights of several females. Okay, your humerus is a bone in your leg. So that's what we're talking about. Part A says use the linear regression feature on a graphing calculator to find the equation of the line of best fit. So again, we would do stat edit. Stat edit is where we need to be. L1, those are your x's, 33, 25, 22, 30, 28, 32, 26, and 27. There are a lot this time. Okay, your L2s, 166, 142, 130, 154, 152, 159, 141, 145. Okay, once you have them in, stat, calc, linear regression. Press enter until you get an answer. This is what you should have come up with. So the equation would have been y equals 3.05x plus 63.53. Okay, find and interpret your correlation coefficient. Your correlation coefficient on your calculator should have been r equals 0.98. This is awfully close to positive 1. That would be a strong positive correlation. Strong positive. It's very, very close to positive 1. Does the data show a linear relationship? Well, like we talked about, when it is a strong positive correlation, that means all the points on the graph are very, very close to a line. So yes, they do show linear relationship. The last part says estimate the height of a female whose humerus is 40 centimeters long. Okay, so it tells us our x, it wants us to estimate the y, and we have the equation. So we know our equation is y equals 3.05x plus 63.53. It wants us to find y when the humerus is 40. Y equals 3.05, x is 40, plus 63.53. So plugging that into your calculator, you should get y equals 185.53 centimeters. All right, if you missed any part of this, please, please, please go back and rewind, listen again, make sure you understand. When you are finished, I have a worksheet for you guys. It will be due at the end of class. Please, please keep in mind that all of these questions require you to have a calculator. This is classwork and will be due at the end of class.